Welcome to everybody on this webinar entitled Flow Assurance for Heavy Oil Offshore Production. The company name is Fluids in Motion Limited, and my name is Kashmir Johal. I'm the Managing Director of the company. And we also have Dr. Jagmohan Singh from EMP ONGC or ex-EMP ONGC, present in India, representing us. What I would like to do is to go through this agenda. I'll go through very briefly Fluids in Motion oil and gas consulting company experience, and especially flow assurance expertise, and then move on to heavy oil, its characteristics, production challenges and opportunities. And I'll talk a little bit about renewable energies, because, as you know, oil and gas is becoming not so nice a word with respect to the environment. So we need to also consider renewable energies. I'll go through some very brief training courses that we conduct, and then provide a conclusion, followed by a question and answer session. So we started operating in 2002. We have a working relationship with other consultancies on an as-when required basis. I have over 40 years experience in the oil and gas industry, and some of the assets we've developed some very powerful software that can model operations from the reservoir all the way to your point of export of oil and gas. Short-term strategy for us is to expand in the Indian, Middle Eastern, Far Eastern sectors. We are heavily involved in developing innovative technologies, and we provide a special service for subsea as well as onshore field development. Currently, we are heavily developing renewable energy technology. With our expertise and software resources, we can very quickly identify fields for evaluation and acquisition to large organizations, as well as banking or financial institutions. We undertake screening studies to provide optimum strategies for the field that we want to develop or operate through an integrating reservoir, well, pipeline, host facilities, and evaluate alternative reservoir depletion options, well production enhancement, multi-phase and transient operation analysis, and a range of feasibility studies to assist and help in the development or exploitation of the field. So as part of the detailed design, we do development of operating philosophies, evaluation, optimization of the production operations to make them as simple as possible, technical audits and reviews, and application as and where possible for innovative technologies. Obviously, project managers don't like new technologies unless they be tried and tested. And we also represent operators and contractors during the whole range of the studies, from initial bids, front-end engineering designs, as well as detailed design. And this is one of our software field options, so we can model everything you can see here, from the reservoir, the seabed, production wells, Christmas trees, connection systems, the jumpers between the tree and the manifold, flow lines, the insulation on the flow lines, risers. And the reason for this is to answer a number of questions. In other words, for the field that you want to develop or have developed, what's the best technology? Is it gas lift or is it natural flow? Is it, do you need downhole ESP pump or multi-phase pump on the seabed, or do you need to separate on the seabed and transport the fluid separately? What are the flow assurance kits? What's the best reservoir recovery option to maximize the oil from the reservoir and to enhance production through the production well? And the thing that makes the world go round, what's the lowest cost option? So these are things that can be answered by our Python software. In terms of flow assurance, we can split these into three areas. What causes blockages in the flow path? What about the integrity of each of the systems that you're going to design and develop? And what are the operational issues? From the blockages, scales from the water composition may precipitate various elements from the water, such as barium, strontium, generally for oil and gas, paraffins, wax, and asphaltenes, based on the characteristics of the oil, gas hydrates. In other words, if you mix light hydrocarbon gases with water, you'll get hydrates like ice. Emulsions, a mixture of oil and water, and sometimes foaming across high pressure drop chokes and valves in the system. With respect to integrity, main areas are corrosion, typically from CO2 in the light hydrocarbon content and water, production of sand, which erodes the metal, especially as the sand is passed with high velocity through bends or other pieces of equipment like valves, and flow-induced vibrations, resonance that may be caused due to production. Operationally, liquid slugging has been around for many, many years. There's no one simple solution. You need to look at each field and fluid properties on their own. Low as well as high temperatures can also be a flow assurance issue. And if you can grasp all of these, they're all very, very critical to the production of oil and gas from onshore or offshore facilities. In simplistic terms, these are the sort of parameters you need to understand in assessing flow assurance. What the reservoir pressure and temperature is, well depth, water depth, and the distance you want to transport to a host facility. It may well be onshore. So the question is, nobody in the world now likes the fact that we're reducing hydrocarbons because they're so polluting. We've got to find a solution to the pollution aspect, especially CO2 in the oil and gas industry. But in the meantime, why do we need oil? Let me go through and explain why then. One of the highest consumers of energy is the US. And per capita, it's about 11 kilowatts. If we take 5 kilowatts as being the average for the world, and world population is 7 billion, we need something like 35 billion watts per day. Now, if we were to replace this over a period of 25 years, look at what we would need in terms of different renewable energies. If it's nuclear, we need almost 4 nuclear plants to be built, 1 gigawatt per day. If it's wind, we would need 53 turbines of 3 megawatts each to be built every hour. If it's solar, we need to cover 255 square meters installed per second. If it's bio-based, we probably all starve because we probably don't have enough bioenergy. However, we need to consider maybe all of these in addition to oil and gas during this transition phase. By the way, oil will be around for many, many years. So coming on to heavy oil, what is it? It's simple. It's high density and high viscosity. So these three pictures on the left, they can be flowing. Ideally offshore, that's what we need. We need a flowing, high density and high viscosity oil, or the one in the middle. It can also occur, which means we need to use technologies to make it much more flowing. The one on the right is basically onshore bitumen. Classification. We classify heavy oil as class A, which is sometimes classed as medium heavy oil. API gravity between 1825 and viscosity strength is 175. And generally, the oil flows in the reservoir, and the reservoir conditions of pressure and temperature. Class B is extra heavy oil, where the API is much lower, 7 to 20. Viscosity is high, 100 to 10,000. Also flows at reservoir conditions. And hopefully these are the ones that we have offshore. Then Class C, the viscosity is much higher, and Class D oil shale is its mining extraction. And this is a classification provided by Total in some of the fields that have been developed over a number of years, and it's Class A and Class B offshore that have been considered for being developed or producing at the moment. Heavy oil reserves by region, and this shows that the American continent, both north and south, have the lion's share of heavy oil, although it exists in other parts of the world. And heavy oil reserves by type, you see, it's luckily for us, Class A and Class B is the lion's share, almost 50%. So that's good news. World oil reserves by oil type. Now, we've been producing conventional oil, which is only about 30% of the total oil that's available. And extra heavy oil and heavy oil is almost 20, 30, 40% is heavy oil. So there's a lot of energy out there, but we have to make it environmentally viable. So heavy crude oils, 10% have been produced at the moment, approximately, maybe a bit more or less now. Non-conventional crude, extra heavy oil, examples are from Venezuela, API less than 10, bitumen Canada less than 10 API. Majority of heavy oil between 10 to 20 APIs produced in sandstone reservoirs in California, China, Indonesia, Latin America, and they've been producing for the last 10 to 15 years, or maybe some even longer than that. Generally, coal production and steam enhanced recovery are some of the techniques used. Huge discoveries in carbonate reservoirs, and the formation of carbonate reservoirs are fairly complex with respect to varying permeability and porosity in the same formation. So it makes the simulations more difficult. There are many naturally fractured reservoirs, which is good news. Only a few carbonates have been produced at the moment. Pilot steam injection projects in Kuwait, Saudi, and Oman. Maybe some of these are now beginning to be produced. Lessons learned, certainly in the UK continental shelf sector, is as follows. Because the demand is increasing, population world is also increasing. There's a requirement to now consider heavy oil fuels. And this has become possible in the last 10 to 15 years. There are, as we just said previously, substantial reserves with crude less than 20 degrees API in the UK CS sector. Activity 10 years ago was confined to exploration and appraisal drilling. Main reasons are high uncertainty of the reservoir and fluid properties. If you don't get these correct, then you're designing the system downstream of that incorrectly. So as soon as you can get fluid properties out of the reservoir, you can start serious simulation and design work. There are also operational complexities inherent in heavy oil. Limit the use of conventional appraisal well testing technology. Here in the UK, the method was developed to determine the most suitable technology for testing wells with heavy oil using electrical submersible pumps. ESPs, and on the Bentley field, a solution was tried about 10 years ago. Technical challenges include short weather windows for the assessment of heavy oils in the UK. Maintaining fluid mobility was an issue, especially for surface testing of oil and the associated equipment required. Separating the oil for metering purposes, maintaining accurate measurements, and designing the most appropriate ESP systems. So there are a number of different technical technology options to produce oil. Ideally, you want to produce it straight from the reservoir, natural flow, cold and natural flow, or natural temperature and pressure flow. That's not always possible. In fact, most cases it won't be possible. So some systems are designed called CHOPS, cold heavy oil production systems, or you may go for artificial lift, ESPs. And if none of these work, then you've got to go and provide other forms of energy, thermal heat, for example, cyclic steam stimulation, steam-assisted gravity drainage, vapor extraction process, which involves injecting light ends to mix with the heavy crude oil to dilute it and make it lighter. And if you're very bold, you go for combustion in the reservoir itself, instant combustion and total fuel air injection combustion. And this shows two cases, one in Athabasca in Canada and the other Orinoco in Venezuela. In Canada, the viscosities are enormously high, where thermal production was the only way to actually reduce. Reservoir temperature was very low, 10 degrees C. Venezuela, reservoir temperature was relatively high, 53 degrees C. Viscosity was a little high, but nothing to worry about. And the oil was made of it. In Canada, it's just bitumen, I'm sure. The other method, as I mentioned, in situ heat or fire, involves igniting the oil, burning it in the reservoir, and that moves the oil closer to the production well that you want to extract the oil. But there are high levels of risk and high cost associated with these options, especially if they don't succeed. VAPAC is another option where you inject solvents in the top well, and this mixes with the oil, and the bottom well begins to pick up the lighter oil that is then produced. So some hard facts, let me go through challenges and opportunities. Technology is the key to meeting energy demand and as well as emissions management and producing oil and gas. So the government industry needs to get together and respond through regulations, policies, investment in new technologies, and provide incentives to developers of new technologies. CO2 has to be the solution. We need to come up with CO2 solutions if you want to keep the oil industry producing. Otherwise, we're killing ourselves. Energy efficiency is also another big step towards minimizing or optimizing the use of oil and gas. There's trading schemes in which the polluter pays, but it doesn't help overall. If you have the finance, you can produce and pay for your pollution. So long-term cyclic, it helps, but in short-term, it doesn't help.
Hello.
Hello.
Yeah, sorry to interrupt, sir. Sir, your voice is not clearly audible, sir. Actually,
Louder?
sir, are you using earphones?
Yes, I am. I'm using the earphone.
Okay. All right, sir.
I'll speak louder.
Yeah. You can speak a little bit louder.
Okay. So we require a, a diverse mix of fossil fuel, nuclear power, coal, and gas. But ideally, we want to minimize gas, uh, especially coal, um, for the future. We need to move towards a transition where we go from fossil fuels to renewables, and as well as micro generation to renewable energies. And a few years ago, I remember Tata came up with a car called Nano, and it was one of the cheapest cars in the world to help to reduce accidents which occurred from people riding motorbikes with a large number of people on the motorbike. But it had the issue with that car that if you were seen driving that car, people think, oh, this is a poor man. And so it didn't go that well in terms of sales. And if you can make that electric, that's one solution to minimizing CO2. So at the moment, fossil fuels are still the primary source of energy, where over 80% is satisfied by, by that. 2% by wind and solar. I think that's increased now quite substantially. We require 20% by year 2020, 30%. Decline of easy oil has disappeared. Um, Demand is still increasing. 22 trillion barrels of oil are still in place, according to IEA. 5 to 10 trillion barrels of oil recovery using existing technologies. Difficult oil in Arctic and deep waters. Energy intensive, difficult to produce, high cost to develop. The global energy demand, population increasing to 9 billion by 2050 or maybe more. High demand for energy, and currently fossil fuels. So we're going to throw more CO2 emissions into the environment. Developing countries like India and China extracting capital from the world and expanding their manufacturing. Hundreds of millions of people moving out of poverty, and middle classes are expanding quickly. And what do they want? They want cars, mobiles, TVs, flying around the world, which means more pollution. Increased consumption of fuel plus electricity. Give you an example, China, 2008, 40 million cars, and it's in the region of 150 million or possibly more now. So based on that, we will have to increase production by 2 to 3 million barrels of oil per day, which is significant. Rising CO2 levels, greenhouse effect, increased gas emissions from fossil fuels, increased use of still coal by India, China, US, and EU. CO2 emissions from coal are twice that of fossil fuels, so that's the first fuel we need to get rid of if possible. Coal gasification, carbon capture and storage is one way of solving that problem, and CO2 is definitely unacceptable in the moment. So what do we offer in terms of training? We offer flow assurance for offshore production, designing for transient operations of oil, gas, and water pipelines, flow assurance for heavy oil production, renewable energy selection and design, environmental pollution aspects. We have quite a few patents that we put together for the oil and gas and renewable energy. And I can certainly say that innovation, there's no hierarchy for innovation. Anybody can invent. The question is, who can make it economic? That's the issue. In-house software, we mentioned field options, there's a whole range of other software from surge analysis, transients and gas, liquid lines, as well as gas release, in the environmental aspects and flare stack, commercial packages like Patchy Molder and so on. There's a few other surge analysis software in-house packages we have. And some of the experience we've had just on heavy oil, we're involved in the early stages of Roma West of Scotland, Mangala, Rajasthan, which is very difficult oil to produce. I'll go through that in a bit more detail in a moment. And Kashagan flood insurance whereby artificial islands had to be developed. Roma West 13 API gravity. Porosity was very good, 25%, and flammability was excellent as well. So that was a good news for this particular heavy oil. Mangala, the reservoir temperature was 65 degrees C. The cloud point, this is where wax begins to appear from the oil, was 2 degrees lower than the reservoir temperature. And the pour point, so if the temperature drops below 40 degrees C, you don't get flow of noise. And in addition to all that, you've got very high wax content. So mobility was unfavorable. This is the configuration that was considered by Ken Energy at that particular point in time. And the transport of this oil will be the 2, 4, or 600 kilometers to various refineries in India. Kashagan, there's a 20% H2S, so corrosion was a main issue. And these yellow boxes are artificial islands that have been created. The depth of the water was only about 4 or 5 meters. Renewable energies, we're certainly moving towards renewable energies. We can evaluate renewable energy type and applications to oil and gas. We need to consider as much as possible how we can use renewable energies to assist oil and gas operations. Predict power generation, selection of the process for renewable energy, design, costing, and various operational issues. And we can provide independent advice. We have 4 books that go with the training: Flow Assurance for Oil, Gas, Field Production Transport, Subsea Oil, Gas, Field Technology Selection via Flow Assurance Evaluation, Designing for Transient Operations of Oil, Gas, and Water Pipelines, and Renewable Energy, Nature of Good. So coming back to heavy oil, early evaluation. And the questions we need to ask is there sufficient field data available? And then you need to consider modeling the integrated system from the reservoir all the way to the processing facility. Evaluate technologies for application in heavy oil, and in other words, which technology can you use for this particular oil type? Consider the current design operating constraints that we have for the field. Establish potential to increase production through revised operating procedures. Assess the potential to retrofit new technology. There may be a few out there that we started to produce one, and since then there's been new technology. Can you retrofit that technology to make it economically viable? And then the critical element is flow assurance. You need to assess and then mitigate that ready-made mitigation options for the flow assurance system. Establish the economic benefits and the risks for each alternative. And this is where software like field options comes into play. And the final slide is a marketing slide. We can offer special flow assurance consultancy for subsea onshore long-distance transport and renewable energy. We undertake feasibility studies, support on speeds and detailed designs, innovative solutions that we can come up with, and we provide technology transfer through training and software solutions that we have developed. So we can provide a complete support service. Thank you very much and for listening and your time. Thank you.
Thank you, sir. Sir, now we'll go for the Q&A session.
Okay.
So will you take the questions or should
Yes,
I?
yes, I'll take the question. Thank you.
So should I read the questions for you?
Sorry, I didn't hear a question.
Okay. So first question, what AI and machine learning tools could be used to forecast and monitor flow assurance problems in surface petroleum production facilities?
Can you repeat that question? What?
All right. Sir, what artificial intelligence and machine learning tools could be used to forecast and monitor flow assurance problems in surface petroleum production facilities?
Okay. So the question relates to existing fields that are operating, I suspect. Yes, I mean, that type of tool could well be useful as a data mining. In other words, if you have plenty of data, the field has been operating for a few years, then yes, then you can apply data mining techniques and probability analysis to assist in flow assurance. However, before you get to that stage, there are lots of tools that are available that can assess and identify which flow assurance issues you're going to have to overcome. And the next part is how you're going to overcome those flow assurance issues. Um, the data analysis is going to be, data mining analysis is going to be based on data that's been available for a particular field. Unfortunately, each field in oil and gas is different. There are no such things as this field is identical to field 50 miles away. That's never the case. Operating conditions change, pressure, temperature, water cut, gas to oil ratio. It's, a, it's unlike using these techniques on data like banking data, for example, that doesn't change. With oil and gas fields, there are enormous variables involved. Okay.
Yes, sir. So next question. How heavy oil is testing using DST?
How heavy is the oil for use of ESP? Was that the question?
Yes, sir. How heavy oil is tested using DST?
Yes. Okay. In other words, for heavy oil, what ESP can you use? Yes.
Yes, sir.
Yeah. Okay. Now you have to assess the density of the oil, not only the density of the oil, but what other characteristics of the oil are you trying to produce? If the reservoir temperature is very low, it's not the density, it's it's maybe the wax aspects that you could overcome. How well does your ESP handle the formation of wax? And what can you do with it? What do you need to inject? Chemicals, anti-wax chemicals to actually produce. So yes, so these things can be modeled quite easily. Okay.
Yes, sir. Sir, next question. Sir, what is the relationship between flow assurance and pigging?
Okay. So you can make any relationship you want. Sometimes pigging is a way to solve slugging issues in pipelines. In other words, you're producing production in a pipeline that doesn't remove all the liquid out, and liquid tends to accumulate. So you then have to possibly pig to actually remove the liquid on various intervals. So it's a matter of removing the liquids before they become very large slugs that the receiving facilities cannot any longer handle, and you end up with the system uh, inadvertently shutting down. So there's no direct relationship, but it's a solution. Speaking of a solution to one flow assurance issue, which is either slugging, and occasionally some of the fix can be used to remove the wax. But these are risky operations. Okay,
Yes, sir. Thank you, sir. So next question. So our next question is, sir, how to determine the best technique to produce heavy oil reservoirs with 15-degree API? Sir?